In this example, they're asking us to find the closest point on this curve to the point 1, 4. So what we're trying to minimize, when they say closest, we're trying to minimize the distance. And so we're going to need our distance equation for this. So we've got distance equals square root x2 minus x1 squared plus y2 minus y1 squared. So they don't give you the equation, but when they say the word closest, this is what they're implying. So we're going to find the derivative of this, and then we use the y squared equals 2x to simplify our function before we find the derivative of it. Well, let's plug in an x and a y into the function first. So we have x minus 1 squared plus y minus 4 squared. And then I have x and y, so I want to try to simplify this as much as I can. I could take the square root. That is kind of complicated. Instead, let's solve for x here and divide by 2. It's not that nice, but at least there's no radicals in it. So I'm going to put a 1/2 y squared in for my x. And then I want to take the derivative of this. However, that square root is kind of a problem because I've got a bunch of chain rule here. So I'm going to square both sides to get rid of my square root. So what I'm going to do is minimize the square distance. I'm going to minimize this. If I can minimize the distance squared, that should also be the minimal distance. So if I can minimize distance squared, that's also the same thing as minimizing distance. So I just got rid of my square root by being a little crafty. Here, I could FOIL these first. However, I'm going to leave them alone and just use chain rule because it ends up being nicer that way. So I'm finding the derivative of d squared instead of d. And I'm going to bring the 2 in front, chain rule here, and then times derivative of the inside, which would be 1y, plus, bring the 2 in front, and then multiply by the derivative of the inside, which is just 1. And then let's kind of simplify this. If I bring in my y and my 2, I'm going to have y cubed minus 2y plus, if I bring in the 2 and the 1, I get 2y minus 8, and my 2y's cancel. So that's my derivative for distance squared. And I've got then to minimize my distance squared, I need to set that equal to 0. So if I add 8 to the other side and take the cubed root, I get 2. So that means 2 is the y value, and if I go up to the top, back to that equation, I can plug in 2 there. So x is 2. So I found my closest point to 1, 4 is the point 2, 2.